Hello and welcome back. In this video, we're going to begin our discussion of functions. Functions are one of the most important constructs in computer programming. They are a fundamental building block of how almost every modern computer program is built. So a function is a single command, which when we run that command, will perform some operations that we are able to define and then optionally return one or more values. So if you're coming here from a previous computing course like Pic 10a, you have already encountered functions. When working in C++, like you do in that course, a function might look something like the following. So we need to include some relevant commands. That's our first line, include IOStream. And then we begin our function declaration. We first give it a type declaration so that the C++ compiler will know what kind of output this function offers. Then we give it a name. We'll call it main here. We open up some curly braces, and then within the curly braces, we put the body of the function. And in this case, our body of the function will just send the string to boldly go out to the terminal, and then we'll return the value 0. And then we close the brace, and then we're done writing this function. And then we're ready to load this function into another C++ program for usage. So we have a few components here, right? There's the type declaration, there's the name of the function, there's the parameter declaration given by those empty parentheses in this case, and there's the return value. So Python functions have many of these same components, but not all. In particular, because Python is a fully interpreted language and is what's called dynamically typed, we don't need to use the type declaration to tell the Python compiler what type of object our function returns, because there is no Python compiler. So we don't have to do anything related to type declarations. We also don't need to use any curly braces, but we do need to use a colon at the right place to initiate the body of the function. So let's take a look at this and see how this works. So I'm going to write a function called boldly print. So when I write boldly print, I first write def, D-E-F, to tell Python that I'm about to define a function. Then I give it a name. I'll call it boldly print with an underscore separating them. I use empty parentheses, just like in C++, to indicate that I don't have any parameters to my function right now. We'll add parameters very shortly. And then I use a colon to initiate the body of the function. Then, just like we did with loops, when I go down to the next line, the Jupyter Notebook will automatically indent for me because I do need to indent the body of my function. As we've seen in Python, the indentations do matter. So the body of my function is as follows. I'll just print the string to boldly go. And that's it. That's my function. I don't have to close anything out. I don't need curly braces. I don't even need a return value. The return value is optional. And now I'll call my function boldly print again, because Python is interpreted rather than compiled. My function is ready to use as soon as I've defined it. So this block of code will run just fine. I run, and I indeed see that I have successfully printed the string to boldly go. Okay, so we see that the function syntax in Python is related to the C++ syntax, but it's simpler in several ways. In particular, we don't need curly braces, we don't need a type declaration, a return value is optional. Okay, so now let's add some parameters to our functions to make them a little bit more interesting. So let's define a new function. I'll call it boldly print 2. So I use the def keyword to initiate the function definition, then I write the function name. And this time inside those parentheses, instead of leaving them empty, I'm gonna put just the letter K, and then I use a colon to begin the body of my function declaration. So the letter K is now a parameter of my function. So, and I can use it inside the body of the function. So for example, I'll print the phrase to boldly go K times as follows. For I in range K, print to boldly go. Okay, so now if I do boldly print 2, and I'd run it without anything inside the parentheses, I'll get an error because I'm supposed to add an argument or a parameter. So now I need to add a value, and that value will be interpreted as K. So I add a value, I'll do 2, so to boldly print 2, parentheses 2, And I see that Python has taken my parameter and it's done the phrase, and it's printed to boldly go twice. So k was 2, so it iterated through this loop twice. Okay, so this is handy because now if I want to do something different, I just change the value of k. If I want to do this 4 times, I just change the parameter and I achieve new behavior. Okay, so we can also give default values to these parameters because sometimes we don't want to specify the argument all the time. We want it to be given a nice default value at least some of the time. So let's do a new version. Boldly print 3 has a parameter k and a parameter verb that will have the default value go. I give it a default value just by putting an equal sign and the value inside the function definition. Inside the function declaration, excuse me. Then inside the body of the function for I in range k, I'll print 2 boldly, and then I'll concatenate verb. Okay, so this time I'll do boldly print 3, and I'll do this 4 times. And when I call this, I'll see that Python has, by default, filled in the word go here because I gave it this default parameter to begin with, default argument. However, I can also change it. So I can change to example, sing. So when I do this with by specifying the default parameter, I no longer get the default behavior, I get new behavior that I manually specified, so I print to boldly sing 4 times. For the purposes of code legibility, it's often useful to use keyword arguments. So keyword arguments tell which argument is being supplied which value. So for example, if I do boldly print 3 for sing, just like we did above. So for this example, it's not too hard to see what's going on. I'm not likely to get confused here. But in principle, someone might say, oh, well, I thought, wait, is it k or is it verb that has the value of sing? The code isn't really helping me remember that. So I can instead use keyword arguments to make it very visible to my user or reader which arguments are being supplied which values. I can do k equals 4 and verb equals sing. And when I run this code, I get the same behavior, but in the code I've given my reader or user additional hints about what is being assigned to what. And this can really improve your code legibility. So using keyword arguments is often good practice unless it makes your code just unreadably verbose. When you have the opportunity, strongly consider using keyword arguments when you are calling your functions. Now, that said, when you do use keyword arguments, it's necessary to use keyword arguments after positional arguments. So positional arguments are arguments where we don't use the keyword at all. We just put the argument where it's supposed to go in the function definition. So in our example, boldly print 3 for verb equals sing, for example, the 4, the first one, is a positional argument, and the verb equals sing is a keyword argument. That works fine. But if I switch this up, so instead I'll do k equals 4 and specify sing as a positional argument instead, I will get an error. I can't use positional arguments after keyword arguments. So I next want to talk a little bit about scope. So the global scope is the set of all variables available for usage outside of any function. So if I do x equals 3, for example, and then I just check on x, I see, oh, I assigned x in the global scope. I can now use x outside of any function definition. So that's no problem. Functions create a new scope that's sometimes called a local scope. And the local scope means that variables in the global scope are available in local scope, but variables created within the function's local scope are not available in the global scope. This is a little bit confusing, so let's take a look at an example. So if I'm going to define a function called print x, and it has no parameters, and all this function does is it prints x, and then I'm going to check on what it does. Okay, so if I call this function, it will look for the value of x in the global scope, and we just assigned x a value of 3 in the previous block. So print x is going to print out 3, even though I didn't tell the function that x was 3, it just looked in the global scope and found it. So this behavior contrasts with assigning a variable in the local scope. So for example, let's make a new function called print y, again, no arguments. And inside the function's local scope, I'll define y equals 2, and then I'll print y. And then I'll call this function. print y. So when I do this, I'll successfully print y. Y's value is 2, so I print out the value 2. That's fine. But notice that I defined y in the local scope, which means it's not available in the global scope. So if I try to find y in the global scope, it's not there. So this is an important behavior to keep track of. And in general, this means that you shouldn't define your functions assuming that some variable is defined in the global scope. If you need a variable, you should either pass it as a parameter or an argument, or you should define it within the function itself. Okay, an important related point is that immutable variables in global scope can't be modified by functions, ever. Immutable variables can't be modified, and so they can't, in particular, they can't be modified by functions. So for example, here's a function called new x, and what this function does is it tries to assign x equals 7. We already gave x the value 3, so we're going to try to reassign x. And now if I do the function new x in this local scope, I'll print the value 7, so it looks like I've successfully assigned the variable x to the value of 7. And I have, but that's only true in the local scope. In the global scope, x still has the value of 3. So what actually happened here is my function created a copy, a new variable called x in the local scope, and then used that when executing the print command. But it did not touch the global scope. Now, I don't want to hide from you the fact that mutable variables, variables that can be changed, in the global scope can be changed by functions. Now, I'll preface this. This is usually a bad idea. You should not do this, and you will get points off in your homework if you do this without a good reason. But it is possible. Here's an example. So I'm going to define a mutable object in the global scope. This is going to be a list of captain names. Janeway, so I have Kirk, Picard, Janeway, and Sisko. And I'm going to write a function that will give me the same list, except it will just reverse all the strings. So it'll give me their names backwards. So I'll call it reverse names. No arguments. For I in range 4. Captains I equals captains I bracket colon colon -1. So I'm going to reassign the entries of this list, and they're all going to go backwards. So if I call reverse names, and then I do captains and check the value of this list, I'll see that I have successfully reversed all the lists, all the words in this list. So I have Crick, Drakip, Yonage, and Oxus for the reversed captains' names. So I've successfully modified a mutable variable in the global scope using a function. This is not a good idea, and in a subsequent lecture, we'll describe why it's not a good idea and ways to work around this so that you can still achieve your goals without modifying variables, global variables using functions. Okay, so I'd like to finish up with a brief comment about return values. So far, we've been using examples of functions that print something, but they don't return any value. This is unusual. Usually, you want your function to have one or more return values, which will allow you to take what you just did with that function and use it in future computations. So let's define a function called boldly return. It'll have k equals 1 and verb equals go as its parameters. They're specified by default. And I'm going to return a list to boldly, I'm using a list comprehension. So my list comprehension is I'm going to return the list to boldly plus verb for I in range k. Now I can assign a variable x to the output of boldly return. Let's use k equals 4 and verb equals dance, say. And now I'll check on the value of x, and let's see here. I failed to define, because I misspelled boldly when I tried to call my function. So now when I run this code, I'll see that I have called boldly return with k equals 4 and verb equals dance. And the result of this is that the variable x is assigned to whatever the return value of the function says it should be. So in this case, it's the string to boldly dance repeated 4 times in this list. Additionally, a function can return multiple values if you want. So let's do double your number is my function, and it has an argument j. So when I do double your number, I'll return j, and I'll also return 2 times j. So I'm returning 2 values. Those both just go straight inside the return statement. And then I can actually assign both of them to variables immediately. I can do x comma y equals double your number. Let's say I call it with value 10. And I can check on the values of x and y, and I can see that I have 10 and 20. So I returned 2 values. I assigned the first one to the variable x. I assigned the second value to the variable y, all in the course of calling the same function just once. An important point to note about the return statement is that it immediately terminates the function execution. And specifically, it'll break you out of the local scope and return to the global scope. This means that a return value can be used to terminate a while loop inside a function, similar to a break statement. So let's use an example that we've seen before. We're going to calculate the largest power of 3 below 10,000. So let's do def, I'm going to do largest power below is my function. It has a variable a, that's the number that I want to compute powers of, and an upper bound as my 2 parameters or arguments. And I'm going to start with I equals 1, and then while true, so this while loop is never going to end unless it's ended with a break or a return statement. While true, I times equals a. Then what I'm going to do is I'm going to check if a times I is greater than or equal to my upper bound, then return I. And so when this return statement executes, it's going to terminate the function definition and break me out of the function and hopefully return the value that I want. So let's check largest power below 3, and I'll check for the largest value below 10,000. And I get 6,561, which is indeed the largest power of 3 below 10,000. So I can use this return statement to break out of my while loop when my while loop executes inside a function body. Okay, so that's our first lecture on functions. There will be much more on functions coming soon, so look out for more.